There he is again. Yep. As I mentioned last time in the multimeter video, here's a short tutorial on the Smart Multimeter. My opinion on it, I'll do a few quick measurements and give you my recommendation. Have fun. There's also a manual, even in German. So that's great. Nothing to complain about. And while searching on the internet, I did a bit of research on what the device can do and how smart you can really use it. I came across something else. It's another digital multimeter. This one is from GVDA. It's exactly the same build, even has its own website. It's exactly the same, just in different packaging. And if you buy it directly from the well-known online portal, it's a bit cheaper. Like I said, I have the Kaiweets, which is available in Germany. It's more common here, and you can also get it on Amazon. And now I'm going to test it thoroughly and just see how smart it really is. All right, let's go. So here's the device. In the normal smart mode, as it's called, it always switches back and forth in this green area. That's the smart area. At the bottom is voltage, at the top is resistance, and in the middle is continuity. Up here, the current temperature is displayed, and down here, it clearly says that it's in auto mode. You can also call it smart mode. All the way on the edge, if you press select up here, this nice little device. There's also a small flashlight here. Just by the way, I'm going to turn it off again now. I'm going to turn it back on now too. This is the auto button. So this is how you always get back into this smart area. You can also see how this pointer keeps switching back and forth, waiting for something to happen. And up here are the areas where you can manually measure something. This is the range section. This is the measuring range again, but in manual mode and also in the voltage range. When you measure in smart mode under 1 volt, you have to measure manually. I'll show that again later. You just have to switch it down. Then you can measure properly all the way down to below 200 millivolts and so on without any problems. Let's quickly plug in the probe, shall we? Now it switches over, so now it's actually expecting an AC measurement, meaning an alternating voltage measurement. But here I have another setup. Here, I've connected a few lithium iron phosphate batteries together. Here we have 24 volts, and here it's stepped up again to 48 volts. I'll explain the rest a bit later, step by step. For now, we're just going to measure the voltage. It measures 26.67 volts there. And if I, for example, connect it here, like this, now it's only 1.5 volts. I'd take the 1.5. And it measures that pretty accurately too. It also switches properly, so to 3 decimal places. You really can't complain about the digits after the decimal point. Unfortunately, I don't have a reference voltage source here today, so I can't do this with 100% accuracy to really see how precise it is. The device, that is. Now, let's measure a higher voltage range again. This is after the pack converter. Here we have 42.75, wrong polarity. So without switching, it did everything, just as it should. That would be the continuity test. Now let's measure. Can you see that? This is an old transformer. I used to use it for soldering back in the day. That was a really long time ago. You can see the frequency at the top, 50 hertz, and below, 30.58 volts AC. So it switches over without any issues, detects everything, and immediately displays the frequency as well. Yeah, I just wanted to demonstrate that again. Measurements below 600 millivolts. I've got a voltage divider here. That's 1.5 volts, and those are three 10 kilo ohm resistors up top. So that means it always splits into 500 millivolts each. And here I have, now it should display 1 volt. It's set to auto. It detects it. So it detects 1 volt because this is a voltage divider that basically splits the 1.5 volts evenly. Now I'll take it out again. Then it switches back to auto. And now you can see it's still in auto, so in the smart mode. And now we've got 500 millivolts here. It can't pick those up in auto mode anymore because, obviously, below 600 millivolts, which is the lowest measuring range, it can no longer detect anything in the automotive sector. So now you just press this button. Then this switches the volts. Over here, you can see it. And then he measures 499 millivolts. Actually, it's perfect. He's doing a really good job. You just have to know it. And if you go back over here now, that's 1 volt. But now it's in the manual section. That means he jumped over from the manual area. And if I go out of here now, he's back in the smart section, focusing on cars. And now he's jumped there again. Okay, that's it. That would complete the voltage measurement for now. Let me show you these. The current measurement on the smart meter, the Acute smart meter, honestly sounds a bit overrated. I mean, it's definitely a smart device, but to really call it a smart meter, maybe it still needs a Bluetooth interface or a Wi-Fi connection. I told you, I found a cool feature. When it comes to current measurement, I'm measuring, here it's 24 or 25 volts, and here I've got a light bulb in between. And now I'm just measuring here. I plug one side in here and take a look. It's still set to automatic right now. And now it automatically switches over here to the Ampere range. And when I connect the other side here, it's at 938 milliamps. So without having to switch anything major, it works perfectly. When I pull it out again, and I take this one out again, it switches back to auto mode. I go into the milliamp range, it switches over to milliamps here. So as soon as I move from the regular voltage or the 2 standard sockets to the current measurement sockets, it automatically switches to milliamps or amps. That's not bad. I really think that's a cool feature. Amp range or current from. By the way, I want to show you this real quick. On the back, there are 1, 2, 3, 4, 5 screws. If you loosen them, the fuses are underneath here. These aren't soldered in fuses, they're regular cartridge fuses that you can replace. One is 610 milliamps and the other is 10 milliamps. So I think that's perfectly fine. So the current measurement isn't bad. All right, about the measurement accuracy. Unfortunately, I let out my reference voltage source. So I can only check with some semi-precision resistors to see how accurate it measures. Here I have 11 kilo ohms. Precision resistors, that means these aren't measurement resistors. They have a 0.1% tolerance. So that's 11,000 ohms. And now let's see what it shows. The reading comes out to exactly 10.98. That is a perfectly acceptable result, 10.98. When you look at the numbers, that's basically just a 10 ohm deviation from our target value. You can't really say if that's because of this. So I think this measurement can definitely be considered acceptable. So at 10,000, at 11,000, 11,000 ohms. I think this deviation is really quite all right. I'll try this again with others. Here, I should be getting 200 ohms now. That's 2 times. No, that's right. That's 200 ohms. 200 ohms. And I've connected them in parallel. And that should actually give us 100 ohms. Here, of course, the deviation is also due to from the side of the resistors are definitely a bit different. Resistors seem, well, as I said, with the precision resistors, you can be quite satisfied. It also automatically switches to the correct range. That's actually 680 ohms, but it switches exactly where it's supposed to. No, that's 680 kilo ohms. There, it's written down below. I've secured them up there again. And there are 100 ohms. It's pretty accurate there. So you really can't complain about the precision of the resistance measurement. Now I'll go over here again and carefully monitor the temperature of the environment. And it complains. It doesn't switch automatically for that. Let's switch to temperature. Here we have 22 degrees Celsius and above, 71 degrees Fahrenheit. If I think that's the PT100 and I warm it up a bit, you can see it right away. I once used it to measure soldering iron tips. I wanted to know exactly how much actually reaches the tip during soldering. Yeah. Another measurement. Diodes. Actually, let's go ahead and take the other one. We should probably just take all the others too. All right, now let's measure the diode. It lights up a little too, but you can't really see it. The forward voltage is 1.916. If we reverse it, nothing should happen. Exactly. It works. Now let's turn it one more notch. Capacitance. That's 35 nanofarads. I have some that are a bit bigger. They are 2.179 nanofarads. Everything works as it should. I'm pretty impressed. Resistors. Wait, I actually already measured the frequency with the AC voltage. That automatically switched on up here. So everything works as it should. My statement on this, I wouldn't necessarily call it a smart meter, but it is highly automated. Very useful for hobbyists. They could have installed USB-C there, of course, for the charging device. But let me be honest and tell you what I paid. I think I have paid 29 euros. For that price, it's quite a bargain, I'd say. If you're interested, I'll put it in the video description. As I said, you can get it on AliExpress. It's available under different names like I mentioned at the very beginning. And for home use, it's not bad at all. Oh, right, wait, I just noticed something else. For outdoor use. So if you drag it outside or want to measure something outdoors, it's not great because the display doesn't really work properly out there. As soon as a little sunlight hits it, it's really hard to see the display. All right, then. Thank you for listening and watching for so long. I wish you lots of fun tinkering. I'm going to get almost the same thing soon, but as a clamp ammeter, so basically a clamp multimeter. I'll be showing that one as well. I think I'll be getting it next week, and then I'll just do a quick review of that as well. I kept it short this time. I hope it wasn't too boring. So see you next time. I'm looking forward to it. Bye.